Remember now, this whole MER project was predicated on the idea that we'd be able to use Mars Pathfinder, not just the concept, but the design, the detailed design, because that's where all the work is. Suddenly, the idea of using Pathfinder design started to crumble. The concepts are old, or at least the ideas of the design are the same, but you don't fly ideas, you fly hardware.
There was no strategic plan after that. It was just, you know, take this hill, take the next hill, you know, take the next hill.
You got to believe it's going to happen, or it's just like, why am I doing this? You just have to sort of feed on that confidence. So it's a group psychosis, I guess, is probably the best way to describe it. So
3, 2, 1, start and liftoff of the Delta II rocket carrying the Spirit from Earth to planet Mars.
Load relief kick crate is in, vehicles responding. Vehicles recovering very nicely from the liftoff transients.
Program response is good. 3, 2, start, 0, and liftoff of the Delta rocket with Opportunity, a chance to explore and unlock the secrets of our neighboring planet.
The transients at liftoff. Engine position looks good.
Program response is good.
We had gone through a rather stressful week leading up to landing. One was that we had had a global dust storm. What should we do about modeling this? How do we know that our system's going to work? But what's the other thing? Well, much to our surprise, after months and months and months of successful round-the-clock testing, we finally find that there's some failures that are occurring. We had 3 failures. We said, well, is it fluke? What's going on? What we've discovered is that the software is trying to turn on timers that count down to firing pyrotechnic events that, say, opens up the parachute or inflates the airbag, fires the rocket, or cuts a cable. We're finding that the software wasn't getting around to doing it. It tried, but the hardware didn't work. And there was a problem between the hardware and software that we did not know about until just 2 days before landing, in which case we'll have a failure, guaranteed failure. We're pretty nervous about this.
Show us your uncertainty, show us your estimate of your unknown unknowns, but don't...
Well, the first thing that comes to our minds was that we can manually do it by sending commands from Earth to bypass the limitations that were present during landing to make those pyrotechnic devices go.
It was one of those, you know, there's a probability it's not going to do it. Probability is probably very low, but we have this way to counteract it by sending this real-time command, but we really haven't tested that approach, and so how do you want to play?
Light nav.
Go nav.
The Doppler signature indicates cruise stage separation has occurred.
Copy that.
All systems are go for entry, descent, and landing. We are currently 6 minutes from landing at the Gusev crater in the southern hemisphere of Mars.
MGS is green and Mach is ready to record. Atmosphere entry. 5, 4, 3, 2, 1, mark.
The vehicle has now hit the top of the Martian atmosphere, moving at a speed of 12,192 miles per hour. Downrange distance to the landing site is 437 miles.
You're going through an event like that, where everything that you've worked for so many years is on the line. We had no control.
Current altitude 45,000 feet, current velocity 1,356 miles per hour. Expected parachute deploy in 5 seconds. 4, 3, 2, 1, mark. We are awaiting confirmation the parachute has deployed. Parachute was detected. Lander separation event has been detected. Spacecraft reporting lander is separated. We expect that radar will lock on the ground in approximately 5 seconds from now. Current altitude 8,000 feet. Moving at a speed of 173 miles per hour. We are near our terminal velocity. spacecraft reporting that the radar is in lock and we have a good solution on the ground. Expected retro rocket ignition on my mark. Awaiting confirmation from the spacecraft that retro rocket ignition has occurred. At this point in time, we should be on the ground. Now 6 minutes 37 seconds from atmospheric entry. Still awaiting signal that we are on the ground. Stand by.
In fact, it took me a while to even believe the signal was really there when Polly was saying, Rob, there's a signal. I go, where? Show me. I don't see it yet.
I think my main reaction was relief. I think is probably the main thing. It's like, oh, we made it.
Electronic tone sent from the rover indicates that the rover has landed base pedal down, which means right side up.
It was a thrill beyond thrills, not just actually witnessing what was taking place, but to be able to experience that through the eyes of these amazing individuals who had put their blood, sweat, and tears for this kind of exploration, which is so incredible. When those first pictures came back, everyone was so overwhelmed, and they were so much earlier than had been anticipated. I've always sensed, even during difficult times here at JPL, always a sense of optimism. And I go back to that great line that if you don't take risks, you're not going to learn anything. And that's why this risk-taking is so critical to our future, to improving the quality of life for us, and again, doing everything that we possibly can to inspire future generations to be as innovative.
We're going to egress and then we're going to drive.
The thing with the first images was, we're safe. It's working.